Albert Einstein. You hear the name and you immediately think genius, right? Well, this is the guy who looked at the entire universe and saw something completely different, totally rewriting our understanding of reality itself. But the truly wild part of the story is where these revolutionary ideas came from. See, these universe-shattering ideas didn't come from some fancy university lab or a giant observatory. Nope. They came from the mind of a humble patent clerk in Switzerland, a guy who spent his days looking at other people's inventions and then, in his spare time, completely reinvented physics. You have to understand, for more than 200 years, Isaac Newton's laws were, well, they were the law. They were the bedrock of physics. They just worked. So how in the world did this unknown patent clerk manage to tear down that entire foundation and build something brand new in its place? Well, that's the story we're going to get into. Our story doesn't start with a big bang, but with a pen, some paper, and a quiet desk in the city of Bern. The year is 1905. Today, physicists call it Einstein's miracle year, and for very good reason. While working his day job, he published 4 groundbreaking papers. At first, pretty much nobody noticed, but those papers held the seeds that would eventually overturn everything we thought we knew about the universe. So the first major bombshell he dropped was a whole new theory about time itself. He called it special relativity. And it was all built on 2, seemingly simple ideas. First, the laws of physics are the same for everybody, no matter how fast you're moving. And second, and this is the one that messes with your head, the speed of light is always constant. For everyone. It doesn't matter if you're flying towards a light beam or away from it, it's always the same speed. That one little fact has some seriously bizarre consequences. And this idea completely crashed into Newton's universe. See, Newton thought time was like a giant cosmic clock, ticking away at the exact same rate for everyone everywhere. But Einstein came along and said, nope, time is relative. The faster you move through space, the slower you actually move through time. It literally stretches and slows down. I know, this sounds like something straight out of science fiction. So to really get a grip on it, let's use a famous thought experiment that shows just how strange this reality is. Okay, picture this. You have a set of twins. One becomes an astronaut and rockets off into space at almost the speed of light. From her perspective on the ship, maybe just a few years go by. But, and this is the crazy part, when she comes back to Earth, she finds out that her twin and everyone else she knew has aged by decades. She's still young and they're old. And I have to stress this. As wild as it sounds, this effect, it's called time dilation, isn't just a fun idea. It's a scientifically verified reality. But Einstein wasn't done. Oh no, he was just getting started. He then spent the next 10 years taking on the biggest force of them all, gravity, and this led to his absolute masterpiece, the theory of general relativity. His breakthrough was this. He realized gravity isn't some weird, invisible force that pulls you down, like Newton thought. Instead, gravity is just what happens when massive objects literally bend and warp the fabric of the universe, what he called space-time. The best way to picture this is to imagine space-time is a giant flat rubber sheet, stretched tight. Now, take a heavy bowling ball, let's say that's our sun, and put it in the middle. It makes a big dip, right? A curve. Okay, now roll a small marble. That's a planet nearby. The marble doesn't get pulled to the bowling ball. It's just following the curve in the sheet that the ball created. That curve, that's gravity. It was an absolutely beautiful theory, so elegant, but how on earth could you possibly prove something like that? I mean, really think about it. If a huge object like the sun is bending space, then the light from a distant star passing by it should bend too, right? It should follow that curve. The only problem is, the sun is kind of bright. You can't just look up and see the stars behind it during the day. The stakes here were just immense. If the starlight bent, Einstein would be hailed as a hero. If it didn't, his wild theory of gravity would be tossed out, and he might have just been forgotten. Everything, and I mean everything, was riding on this one single observation. So, in 1919, a British astronomer named Arthur Eddington led an expedition to see a total solar eclipse. This was their chance. For a few precious minutes, the moon would block the sun's light, making the stars behind it visible. He took pictures during the eclipse and compared them to pictures of the same stars at night. The result? The stars' positions had shifted, exactly as Einstein's theory predicted. Space-time bent. Einstein was right. The world was absolutely stunned. Now, you might be thinking,
Okay, this is all fascinating stuff about black holes and bent starlight, but what does it have to do with me? Well, here's the kicker. Einstein's mind-bending cosmic theories have a very, very real impact on your everyday life.
In fact, you use this universe-bending physics every single day. That little map on your phone, the entire global positioning system, GPS, it would be completely useless without Einstein's theories.
Okay, here's why. GPS satellites are whipping around the Earth at incredible speeds. So because of special relativity, their clocks tick just a tiny bit slower than ours. But wait, they're also way up high, in weaker gravity. And because of general relativity, that makes their clocks tick a little bit faster. You have both effects happening at once. Engineers have to correct for both of them perfectly. If they didn't, the clocks would be off and your GPS would be wrong by miles within a single day. And the difference is just staggering. Look at this. With Einstein's corrections built in, your location is pinpoint accurate. Without them, that error grows by more than 7 kilometers. That's about 4.5 miles every single day. The entire system would be fundamentally broken. So at the end of the day, Einstein's theories aren't just for astronomers staring at the stars. They are a crucial part of our modern worlds, humming along quietly in the background, whether we're trying to solve the deepest mysteries of the universe or just trying to find our way to lunch. What Einstein really showed us is that even the things we take for granted, our most basic ideas about reality, like time and space, can be completely flipped on their head by one person with a brilliant idea. It really makes you wonder, doesn't it? What's the next great shift in thinking? What fundamental truth is out there, right now, just waiting for the next Einstein to come along and see it?